Okay, so answering this final question actually proved to be a little bit difficult. We had to do some pretty sneaky computer programming because the numbers got so large we needed to actually use logarithms. But we found online that the volume of a 2n dimensional sphere, so 2, 4, 6, or 8, etc.,
Yep.
is pi to the n over n factorial, times the radius of that sphere to the 2n power. And we know for 2n dimensions what our internal radius is.
Yeah.
Yeah. And so what we found was that if we wanted this to be larger than the box, the volume, we would need pi to the n over n factorial times root 2n minus 1 over 2 to the 2n power to be greater than 2 to the 2n. Now where did this 2 to the 2n come from?
That's the volume of an n-dimensional box, or 2n.
Yeah. You want to pick her up? Yeah, that's the volume of the... Here, no, just give her to me. That's the volume of the 2n dimensional box whose side lengths are 2.
Yes.
But then we could do a little bit of a trick. Pi to the n over n factorial. Is this still on camera?
Yes.
Okay, and then because this is a 2n power.
Yep.
Here, give it to me. Because this is a 2n power, this could actually come in here and just divide that by 2. So we got square root of 2n minus 1 divided by 4.
Yes.
To the 2n greater than 1. So then we could do that, and why was this so difficult to actually just plug into Mathematica? What was the problem?
The numbers got so small that Mathematica just rounded them to 0.
Yeah, because when we were trying to compute this just kind of on its own, we had a weird problem. We're like, pi to the n, and when n was 100, that's a big number, divided by 100 factorial times this.
It's going to be pretty small.
Yeah, so what we did is we computed with logarithms. But we actually did find a dimension. Do you remember what it was?
1,206.
Yeah, that's right. So when the 2n dimensional sphere, so when that dimension, write it down, was 1,206, and so n was 603.
Yep.
We actually got that this was bigger than 1.
Yeah, so that means the sphere is bigger than the volume of the box.
The volume of the sphere eventually becomes larger than the volume of the box in dimension 1,206. And we didn't check the odd dimensions, so maybe it actually first happens in 1,205.
But it definitely happens in 1,206.
It definitely happens in 1,206, which is cool. Shows you high dimensions are very strange. Very strange. All right, good work, hon.